My name's James Grellier. I'm an epidemiologist, and I'm talking to you about a paper that is published in Epidemiology based on an analysis I did with Professor Elizabeth Cardis at IS Global in Barcelona and other collaborators in Europe. Radiation protection guidelines tend to be based on photon radiation, so that's X-rays and gamma rays, and the data on the health effects of those that comes from studies either of nuclear workers who are monitored for photon radiation or from the atomic bomb survivors in Japan. What we're interested in looking at is for those workers that have the potential of inhaling alpha particles, what risk this actually conveys to them in terms of lung cancer. It's hard to calculate these risks using any kind of dosimetry from outside the body, so complex dosimetric models are used to calculate the amount of dose to the lung from urinalysis or some other kind of biological samples. We found a cohort of workers from Belgium, France and the UK, and we conducted a nested case control study in that cohort to basically try to quantify the dose response between alpha particles in the lungs of these workers and the risk of lung cancer. One of the big advantages of this study was not only that extremely complex and good quality dosimetric data was available, but also that we had some data available on smoking for these cohorts. What we found, in fact, is that there is, even at the relatively low doses that these workers have accumulated in their working lives, that there is a risk of lung cancer. And that one of the more interesting points that we found is that the risk of lung cancer actually appears to be higher for plutonium than uranium. We don't have any kind of mechanistic explanation for why that might be the case, so that may just be due to some kind of limitations in the dosimetry in the study. The importance of the findings of this study is that the degree of risk that we see from relatively low doses of alpha particles is similar to that which would be expected if we were to project the risks from photon radiation experienced in other settings. So we can see that the current regulations that are in place for radiological protection, the current use of a relative biological effectiveness of around 20 for alpha particles appears to be approximately correct. So we can rely on the current regulations that are in place for workers.